All right, let's go ahead and do the second type, okay, where we have one log and one variable. All right, so let's look at what that could be. So we're going to have a log base b of some x, right? The log and the variable are attached, equals some number. And we learned last lesson with our inverses that we have a new way of dealing with our exponents, right? Logging or exponentiating. So I am going to exponentiate on both sides. And exponentiating looks like this. Okay? It's where you take the existing equation and you turn it into the exponent. Now we know that with our inverse property that these two things cancel out and we are left with x equals b to the w. That's it. X equals b to the w. You solved for x. Okay, so we used our inverse property and we solved for x. So notice that we only have one log and one variable, and we're trying to undo to get the x by itself. So let's look at some examples here. Let's say we get log base 5 of x minus 10 equals -6. Okay. Notice that I have to think about my PEMDAS because I don't want to exponentiate until I make it to the e part of the solving. So the first thing I'm going to do is add the 10 to the other side. And now I'm going to exponentiate. So I'm just going to underline these two pieces. And, right, I'm exponentiating without having to rewrite the question. Now, my inverse property tells me those two things cancel, and I'm left with x equals 5 to the 4th. Now, you can leave it in exponent form because you did solve for x, and 5 to the 4th is, well, it's 25 times 25. Okay, so x equals 625. Okay, either format is acceptable. All right, so let's do another example here. For natural log of 3x equals 20. Okay, so I still have to think about my PEMDAS. And in this example, I have to divide this 4 first. Okay, you don't want to exponentiate too early. You have to wait until you get to the e part. So we have natural log of 3x equals 5. Okay, now I'm ready to exponentiate. This time I'll rewrite the problem. Okay, so I'm going to use base e, and I'll write my e a little bigger. Okay. Okay, double-sized equals e. Okay, so I'm turning the existing equation into the exponent. And my inverse property tells me, cancel out. So I get 3x equals e to the 5th. Now I'm not quite done getting x by itself. So the last step is you just start back over, and I'm going to divide by 3. Now, personally, I prefer to write this as 1/3 e to the 5th. Okay? Doesn't really matter whether you write the e to the 5th on the top and the 3 on the bottom. They are equal. All right. Let's see if we can't add in another example that might have a couple more operations. Log base 3 of 2x plus 1, okay, minus 2 equals 0. All right. Okay, let's think about our PEMDAS here. All right, so I'm trying to isolate the x. So I'm going to start by adding the 2 to the other side. And then I'm going to exponentiate with a base 3. Okay, now whatever was there, that's what's going to become the exponent. Okay, my inverse property tells me, swoop. Okay, and we end up with 2x plus 1 equals 3 squared is 9. Okay, 2x equals 8, x equals 4. Now, you can go ahead and check this if you'd like, okay? Can I check? Just to be sure. Log base 3 of 8 plus 1. Oh, yeah, it is equal to 2. Okay, let's do one last example before you try the second set in your homework. Let's do, okay, let's do 3 minus log base 2 of 4 minus x equals, 6. All right, I am thinking of my PEMDAS, and I notice that I've got this 3, so I'm going to subtract this 3 first. And then I'm going to divide by this negative in front, okay? Divide by -1. Okay. And now I have reached the exponentiate part. So I'm going to double size my letters. All right. Exponentiate. And whatever was there, the whole thing, right? Goes into the exponent spot. Now I know my inverse property looks like that. Now 2 to the negative 3 is 1 over 8. All right. Now you haven't solved for x yet. We still have to keep going. So I'm going to minus 4 from both sides. I'll do a little bit of arithmetic over here. Okay, 1/8 minus 4 is 1/8 minus 32 over 8. Okay, so that's minus 31 over 8. There's my arithmetic. So we have negative x equals minus 31 over 8. So x equals positive 31 over 8. Whew. All right, good work. Okay, go ahead and try that next set of problems.